Hello YouTube, welcome to go over the last project, which is going to be project 3 of our introduction to reinforcement learning series. So we're going over this series for reinforcement learning for absolute beginners. We're going to learn reinforcement learning from a very basic and fundamental point. And while doing this, we're going to be building 3 different projects. So in the last tutorial, we built a project about training a reinforcement learning agent to learn a spacecraft. And in this tutorial, we're going to go ahead and we also build one project about self-driving cab. In this tutorial, we're going to go ahead and do project 3, which are going to train a catapult balancer. So that's what we're going to be doing. So let's go ahead and get everything set up to begin. So I'm just going to go ahead, create a simple notebook here. Create this notebook here. Again, if you're new to the channel, please kindly consider subscribing to the YouTube channel and liking this video. Also hitting the notification bell so you can stay updated whenever I upload future videos on reinforcement learning, machine learning, web development, and data science. So thanks for watching. Let's go up to it actually. So I'm just going to be, this is going to be project 3. So I'm going to say project hyphen 03. Okay, so in project 3 we're just going to give it a name. We're going to call it catapult balancer. I'm just going to catapult. I'm just going to say catapult, just like that. So what's all this thing about catapult and what does it mean and all that? So you're going to go under controlled, I think it's classic controls. Go under catapult and you'll be able to see the documentation for catapult, what it means and what's all it's all about. Okay, so just basically we're going to train so they say you have a cat and then on the cat there is a pole, right? So the task of the reinforcement agent is to balance the cat such as the pole doesn't fall off, right? So we have all the stuff here. So you can see the action space is just 2 action space, either the one move to the right or move to the left, and then we have the observation space, which gives us the cat's position, the cat's velocity, the pole angle, and then the angular velocity of the pole. Okay, and all that information. So there we get a reward of maximum reward of 475, and if we hit that reward, then we are done basically. So let's go ahead actually import everything in it and get started. So I'm going to go ahead here and let's make a comment here. So it's going to be step 1, import libraries, just like that. And I'm going to go ahead and say import. I'm going to import OS, import gym, and I'm going to say from stable baseline 3 dot common dot vec environment. So we want the vec environment. We want to go ahead and import the dummy environment. So I'm going to say dummy and then just dummy vec environment, and I'm going to say from stable baseline 3 dot common you're going to say evaluation. You're going to go ahead and import the evaluation policy for evaluation. Then we say from stable baseline 3 I'm going to go ahead and import PPO. So PPO stands for primal optimization policy. Primal policy optimization, right? If I'm not mistaken, I think that's the name, primal policy optimization algorithm. Okay, so we're going to be using this algorithm for this model balancer. Okay, catapult balancer. Okay, so once we have the libraries imported, what next? So let's load up the environment. So I'm going to make this to be step 2, and step 2 is just load environment. I think there's no E here. Okay, so if I'm wrong, let me know in the comment section below. So to create the environment, you're going to say env is going to be equals to gem.make, and then you're going to go ahead and specify the environment, name of the environment, and you can find it right here, which is just catapult version 1. So I'm going to simply go ahead, copy that, and go back in here and simply paste it in here. Great. So we have an error right here. So it said catapult, let me see, attempts to look multifunction environment catapult. Okay, let's try to look. Maybe you haven't installed something. So let me just go in here and click on this. Is there anything that we need to install? Yeah, we need to install this. So copy this and then go back in here, and then simply we can install it right here. So I'm going to go above. You're going to use this, then paste it right here and run that code. So that's going to go ahead and install everything. So everything was installed. So why we getting the error? So it says that catapult attempt to look up malform environment catapult current ID must be form of this. Okay, did I make okay, there's an error right here. So run that. So sorry for that. So once I have that out of the way, so now we're going to say episode. So episode and episode is just going to be going to use 5 episodes just to keep things simple for now. I'm going to say for episode in range episodes So for episode, there is episodes, right? What you're going to go ahead and do is you're going to say state, and the state is going to be equals to we're going to say env.reset, right? You set the first method you're supposed to call after creating an environment, and you're going to say done is going to be false, and you're going to say reward, the reward underscore count, and the reward count is going to be by default 0. Okay, so once I have that, I'm going to say while not done. What we're going to do is, let me just scroll up here so you guys can see. I'm going to say env.render, and then I'm going to say select the random action, and it's going to be env.action space .sample, and then you're going to select a random action, and you're going to now apply the action. So I'm going to say state done, reward done, and then info equals to env.step, and you're going to pass in the action. Okay, I'm going to pass in the action there, and you're going to now say now going to update. So we're going to say reward count, right? Reward count plus equals to reward so plus equals to the reward, and then you're going to say state is going to be equals to the new underscore state that we get back. Okay, and now you can go ahead and say print. You can print. I'm going to use an S string here, and this is going to be episode, and episode is just going to be the episode that we want. So we're going to say episode right here, and let me close off this, so delete that, close off this, and episode, and then you're going to say score, and the score is going to be the reward. So reward, just like that, reward count, right? So reward count. And once I'm done, I'm going to do env.close, just close, right? env.close, because it's a good practice to close everything that you open up in programming. So once I have that, I'm going to simply run it, and okay, got an error right here, so it's going to be episodes. Yeah, so this is basically it. So 5 is really too small. Let me make this to be about 10, and then run it. So you can see the cut and do the pull, and it's trying to balance it by moving either left or right. Right, so now let's go ahead and actually train. So you can see this is it's not it's an easy problem to solve, and you can see the model is getting some good scores even without training. Okay, and the maximum score you can get is 400 and let me just check, 475. Yeah, right here. So you can actually use other environments if you want. Once you have learned the basics, there is also the mountain car and all this. Okay, so let's continue with it. So we have done that already. We have looked you can look at the different action spaces and the observation space like we did when we're working the spacecraft. Okay, but I'm not going to go that. I'm just going to jump straight into training it. So I'm just going to say go into training. So I'm going to simply go here and say train model. Okay, so to train the model, you have to say create an environment first, and it's going to be gym.make. Actually, you can just go ahead and copy this from here. So copy all of that. So copy, and then down here paste it again. So paste it. Okay, let me down in extra space up here. So delete that, and I'm going to say env equals to dummy environment vect, and I'm going to pass in a list, and I'm going to say lambda, and lambda is going to it is a list. Yeah, lambda is going to be equals of type env, just like that. And once we have that, I'm going to define the model, and the model is going to be a primal policy optimization model, and you're going to be using the multi-layer perceptron policy. In another project, I will also show you how to use the CNN policy or the multiple input policy. Okay, so we have specified the policy, we have specified the environment, we have specified the verbose. So verbose is going to be 1 because we want to see a verbose, and then you can specify the Tensorboard. So you can just actually go above, create here, and you're going to say this is going to be log underscore path, and it's going to be os.path.join, and you're going to join the train and the logs. Okay, and it's going to be logs. Yeah, just run that, and you're going to say this is going to be Tensorboard. So we're going to pass in the log path because we want to see how it performs in the Tensorboard, right? So that's run, and I'm using CUDA, I'm using GPU. So if you're using CPU, don't worry, it doesn't really affect in reinforcement learning agents are not much affected by CPU. So even GPU, even it's not affected. It's not a must that you have to use a GPU. That's what I mean to say. Okay. So PPO stands for proximal policy optimization. So I've been mentioning the wrong thing. It's actually proximal polity optimization and not primal polity optimization. It's proximal polity optimization. So let me actually write it here. So write it here, and I'm going to say PPO. This is going to be proximal. So proximal policy optimization, just like that. That's okay. This is a markdown cell, so I'm going to make the markdown and run it. So proximal policy optimization, that's what PPO stands for. Okay, once we have done that, you can, if you want to read more about PPO, you can find more information just by doing this, and you get more information right here. Okay. So once we have that done, I'm going to now go and train the model. So model.learn, and I'm going to simply say total timestamps, and I'm going to use this 10k. Okay, so 10,000, and then run that. So that should now start training, and we should okay, now that goes okay. Okay, now that goes training, and so you can see we have the different evaluation matrices. We have FPS, frames per second, we have the loss, the number of updates, the policy gradients, the value loss, and all that. So clip entropy loss and all that information. So we talked about the different matrices for each algorithm, right? So the last algorithm we saw had different matrices compared to this algorithm that you are looking at right now, right? Okay, so it's done training, and you have to those timestamps that you're taking is this much. So that's quite quick. So once we have done that, so I'm just going to go ahead and copy this code right here. Copy it right here. I'm just going to copy it, and I'm going to move down, and here I'm just going to go ahead and simply paste it here, and this is going to be model.predict, and you're going to pass in the state right here, and you're going to pass get action, and then another thing, so you're going to escape using an underscore. Yeah, so that's basically it, and make sure that you update your model right here, right? Because one day I was building a model and I forgot to update my state, and I didn't actually get any good thing because I thought the model was doing bad, but really it wasn't. So here is our reinforcement agent, and it has a score grade. It has really good scores for 200 and above, but you can maximum is 475. Yeah, so you can actually train this to do even better than the way it's doing right now, because it's trying to balance the cut pole, and you see it's moving left and right to balance it. Yeah, so you can see these are the different scores, and you can optimize this to get even greater scores. Okay, yeah, so we have looked at how we can train this to even get a greater score. So let's go ahead and try to see something else. What I want to now look at is see how we can change the policy to even get a better accuracy from our model. Okay, so I'm just going to look at how we can change the policy here, because when using deep learning with stable baseline 3, it uses machine learning neural networks in the background, so it can actually affect the change the architecture of the neural network that is used to train this. Okay, so that's what I want us to do. So let's just minimize this, and okay, so that was step I didn't actually write a step. That was step 3. So step 3, let me keep it here so I don't lose track of it. So this is going to be step 3, and now let's move on to step 4. So step 4, we're going to just do here this, and then we say step 4, which is actually changing change policy, or the neural network architecture basically. So to do this, you're going to simply go ahead and say model equals to PP, right, proximal polity optimization, and then you're going to say MLP policy, multi-layer perceptron policy, and you're going to pass in the environment. The verbose is 1, right, because we want to see an output, and then the Tensorboard, and it will be log path, and then you're going to now pass in other stuff. So you can now go ahead and see how we can optimize the neural network that is used by this model. So do this, I'm going to say I'm going to simply go ahead and say net architecture, and this is going to be the following. So it's going to be a list of dictionary containing a dictionary, and inside of this dictionary we're going to have a pi, right? So pi, and it is going to be equals to, and then in it providing how many layers we want and the number of neurons in each of those layers. So I'm going to say 128 by 128 by 128 by 128. So we have 4 different layers, and each layer has 128 neurons inside of it. Okay, and you're going to now say the value function. So the value function is going to be the following. So the value function is going to be a list as well, and it's going to have 128 by 128 by 128 by 128. Okay, 4 of them. So I'm just going to go ahead and execute this right here. So in here I'm going to go ahead and specify the policy quirks, so you can run the policy quirks, and then you can pass in a dictionary, and first you can say net underscore arc network architecture, and this is going to be equals to the net architecture that we define above. So just run that. So that's basically it. So now you have done this, you can go ahead and simply train a model again. So you can copy all of this and just go down here and simply paste it right here and run this. So this is going to go ahead and simply go ahead and train our model again, but now it's using a different neural network architecture that has 4 layers. Each layer has 128 neurons. And yeah, so that's basically. So let's give it some time to train this, and once it's done, we can see how it performs. Yeah, so our model is done training, and you can see all those values are here. So let's actually see how it performs. Let me just minimize this again, and let's run this again to see how that model does. And you can see just by checking the neural network architecture, our model does significantly well and gets better accuracy, right? Yeah, so that's basically it, and you can see we have 500, right? Score 500. That's really great, but the maximum is 475, but now we are reaching up to 500 just by changing the neural network architecture. Our model is balancing the pole really well. Okay, yeah, so that's basically it. So now we can actually go ahead and actually try to add a callback to our model, so that our model does not overtrain. Once we reach a certain threshold of 475, you can simply tell the model to stop training, so you don't overtrain our model. So to do this, what I'm simply going to go ahead and do is I'm going to go down here, and I'm going to simply say create. This is going to be step 5. So create this is going to be step 5, and I'm going to simply say add callback, right? Add callback. Callbacks. Okay, so run that, and I'm going to say from stable underscore baselines, right? Let's actually wait for this to complete. How many episodes is this going? Okay, sorry, how many episodes is this going? Let me check. Okay, 10 episodes, so we have 4 more to go. So let's just give it some time to complete that. Yeah, so that's done completing, and you can that's done running. So you can see we have all the scores here up to 500. So that's really good just by changing the neural network architecture. Okay, so I'm just going to go here, and this I'm going to say from stable baselines 3 dot common dot callbacks. Right, I want to go ahead and import the evaluation callback. I want to stop training on reward threshold. So import those two, and then simply run it. So I'm going to go ahead and simply say stop underscore callback. This is going to be the stop callback, and this is going to be equals to the stop training on stop training. So stop training on reward threshold, and then you're going to pass in the reward threshold, and the reward threshold is going to be 475, right? 475, and this is from the official documentation. I think it's somewhere down here. 475. Yeah, this is it right here. Yeah, so that's all we need, and you can say verbose, and you can say verbose to be true. Okay, so once I have that, I can just run that, and I can say evaluation underscore callback, and evaluation callback is going to be the eval callback that we imported. This is a class, and you're going to pass in the environment. You're going to pass in the callback based on the callback on the new best. Okay, and this is going to be equals to the stop back. Okay, stop back, and then you're going to say the part to save it. Now we're just going to leave that for now. Just say verbose, and the verbose is going to be equals to 1. So up here I'm going to go ahead and specify the path to which we want the file to be saved. Okay, so I'm going to create a cell above here. I'm going to call it save underscore path, and this is going to be equals os.path path, just like I did in the last tutorial. So os.path.join, and then you're going to say train is going to join train with saved underscore models, and then run that. So we're going to use this right here and paste it here. So run that. So once we have this, we're going to say model dot ppo, right? And then we're going to use the multi-layer M is a capital, right? So M multi-layer perceptron policy. And then you're going to go ahead and say the environment equals to the environment, the verbose, sorry, no, this is going to say Tensorboard, tensor, okay, let me just see, it's going to be tensor, let me see, Tensorboard underscore log, and this is going to be Tensorboard log is going to be equals to the log path that we have. Okay, so run that. Has no attribute ppo, so ppo has no attributes ppo, so okay, this is actually model equals to, so my bad there, so model equals to that. Okay, then run that. So once we have that, you can see model, we can do model.learn, and then we just let the model learn. So we can just say model.learn, and you're going to simply show the total timestamps, and this is going to be 100, 10,000, and you're going to say the callback should be the evaluation callback that we defined above, and you can specify the policy that we had earlier on. Then the policy is going to be this one, so you can simply copy this from here and simply go ahead and paste it here. Okay, so if you want to find out more information, policy quirks, got unexpected keyword argument policy quirks. Okay, let me see. Okay, this is not supposed to be used here, so I'm just going to undo that, and it's supposed to be used, let me see, at the point of creating the model. That's what it's supposed to be used, which is this part right here. So yeah, and then run that. So once we run it down, this is going to go ahead and simply go ahead and train the reinforcement agent, and it's going to train it for 10,000 total timestamps. Okay, so let's just give it some time for that to get completed. Okay. Okay, so now you can see it says that the base reward has been reached. Mean episode reward is 307.77 average. That's it says the base model reward has been reached. So let's actually try it out and see how it does here. So yeah, it does really good. No, actually it does really bad because we lose the scores that we get. So why is it saying the mean reward has been reached? Threshold is 414.75. Okay, yeah, it's doing good in some cases. Yeah, if you see the score is here, it's not that bad, but previously we were having 500 just by without specifying the threshold. We got 500. Okay. Yeah, that's basically it. It's fine for now. I'm quite okay with that. So what I want us to do right now is actually go ahead and save the model. So let's go ahead and actually save the model, and that is going to be step 6. So I'm going to make it step 6, and it's going to be save model, just like this. And you're going to say we're going to say model, just like we did last time. We say model, make this a constant. So I'm going to say model underscore path, and the model path is going to be equals to the following. So the model path is going to be os.path.join, and you're going to go ahead and specify train. It's going to go in train saved underscore models, and you want to join this with a model name, which you're going to call this one ppo underscore cat poll. Okay, underscore model model just here. So once I have that, I can do model dot save, and then pass in my model path, which is going to be the ppo, the model path. Okay, variable. So once you have that model saved, let's delete the current model that we have. So I'm just going to say delete model, and what I'm going to simply say is a del and then model. Okay, so once I have that done, I'm going to now go ahead and reload the model. So it's going to be step 8. So it's going to be step 8, and it's going to be reload model. And to reload the model, we have to say model equals to the PPO, right? Whatever model that you use to build the model, this was a PPO model, so I have to use PPO to reload it. So if you use PPO, then you can use a DQN model to reload it. No, it won't work. So when we say this is going to be model path, and then we say the environment is going to be environment that we have. Okay, yeah, so that's basically it. And once we have that done, we can evaluate our model. So let's evaluate the model. So let me just go to, this is going to be step 9, and it's going to be evaluate model, and this is going to be evaluation policy. We're going to call the evaluation policy function, and we're going to pass in our model and our environment. Environment is going to be the environment that we have. Yeah, and then you're going to pass in the number of evaluation episodes. And I'm going to say, let's say this to be 10, and then render is going to be true. So run that. So yeah, so you can see it's literally just it's balancing it so perfectly that it looks like it's just a picture, right? But it's actually moving around and try to balance it. So it's really perfect, and it's trying to balance it just on spot. So it's doing really a good job. So you can see the model is perfectly balanced at the moment. Yeah, so the model is really good. So that's our reinforcement agent trying to balance a cat on a pole. Okay. Okay, so once we have that done, let's actually try to view the performance of this. So I'm just going to say view performance. So this is step 10, and it's going to be view performance. Okay, let's say view performance on Tensorboard, and this is going to be, you're going to import Tensorboard just like this. Okay, so this is still running, so let's give it some more time. So we're going to import Tensorboard, and we're going to specify the log path. So I'm going to create another cell below here, and we're going to call it training underscore log underscore path, and this is going to be equals to os.path.join. So we're going to pass in the log path underscore path, and you're going to pass in the PPO underscore. Let's see which one we get. So this is go to train, go to saved models, not this one, it's going to be here. I think in the log, sorry, the log path, right? So it is PPO 3. Okay, so PPO underscore 3. So right here it is PPO 3. So we go down up here and we say PPO 3. So you can see now our model is done training, and you have an overall mean reward, average reward of 450 with a standard deviation of 77. So great, so that our model is doing quite well. So now we can simply go ahead and simply specify this path, and once this path is specified, you can simply go ahead and view this using Tensorboard. Okay, to view this with the Tensorboard, it's quite simple. What you simply have to do is just you have to say exclamation magic method and say tensor. Okay, I have to import Tensorboard, so run that and say Tensorboard, and then you have to say hyphen that's going to log dir, and the log dir is going to be equals to the training log path. So run this, is going to open up a server running on localhost at port 6006, and you can see the performance of the model right there. So it's a bit strange. Yeah, so as we have trained for, mean reward was around 400. Okay, for all times it was around the same reward, so it wasn't really improving. Also for the mean episode length was around the same value, and then you can see the frames per second was actually dropping as we go along. So these values didn't actually change, but it's the same value. So our model is doing really great. So I'm just going to stop that. So our model is doing really great. So that's basically what I wanted us to cover. So we have learned all the basics of reinforcement learning in this series. So we learned about how to install the libraries, how to import the libraries, how to create an environment, how to just pick a random action and apply it on the environment, how to train a model using stable baselines 3, how to evaluate the model, change the model architecture, the policy, be able to specify a callback, be able to save our model, reload the model, evaluate the model's performance, view the performance on Tensorboard, and all that stuff. Okay, so I built 3 projects: self-driving car, the spacecraft, the lunar lander, and also the this one, the cardboard balancer. So these are all the projects that I wanted us to build. This is a basic introduction to reinforcement learning. If you guys want me to make more videos on reinforcement learning, let me know in the comment section below. I'll do my best to make a video on them. So if you're new to the channel, please kindly consider subscribing, liking this video, and hitting the notification bell so that you can stay updated whenever I upload future videos. Also, don't mind sharing the video with any of your friends who is working with deep learning or reinforcement learning, anything like that. Please kindly share the video and connect with them. Share it to your friend groups on WhatsApp, on Facebook, and on Discord, and all that other community. Thanks for watching, and see you in the next one. Keep safe.